Okay, let's have a quick look at how to do this question. So in this question, you're given the confidence interval, and you're given the data, and you're asked to work out what was the confidence level. Okay, so it's sort of twisting the question around to sort of test your understanding of what's going on. So let's look at what we've got. We've got the confidence interval and we've got the data. So if we've got the data, we can use our calculator by putting the data in, which I've already done here. So I put the data into this second list, L2, and we can calculate the statistics based on that list. So we go to stats, calculate one variable statistics, and this time we go second L2 and we change it there to L2. We can then calculate the statistics for that list. So for this list of data, we now know that X bar is 26.75. We know SX, which is our unbiased estimator of the standard deviation, is this. And we know this is our sample standard deviation, and we know n is 4. Probably could have worked out because we can count to 4. So let's write that down over here. So we know that X bar is 26.75. We know that SX, which is Sn minus 1, just get used to our notation, is 5.737. We know that sigma x, which is Sn, is 4.969, and we know that n is 4. So how do we work out this confidence interval? Well, what we do to work out a confidence interval is we do X bar plus or minus t times, well, it depends on what we do. We've got two choices. We could either do Sn minus 1 over root n, or we could do X bar plus or minus t Sn over root n minus 1. We can use either of these. Doesn't matter which one we use. So let's look at the top of this confidence interval, this 31.448. So that's obviously been done using a plus here, not a minus. So we could say 31.448 equals X bar, which is 26.75. Let's just use this top one here, plus or minus t, which we don't know. Sn minus 1 is 5.737, and root n is root 4, so 2. If we rearrange this, we can say that t is going to be 31.448 minus 26.75 times by our root 4, so 2, divided by 5.737. So we get a t value of 1.6378. Okay, so therefore our t values are going to be plus or minus 1.6378. So if we repeated this process using 22.052 in here, we get minus 1.6378 because our confidence interval is symmetrical about the mean. So let's draw a picture of our t distribution. So the t distribution will look like a normal distribution. So what we're being told is we don't know the confidence interval, the confidence level, but we do know there are two values here. And on our original one, we know it goes from 22.052 to 31.448. But what we've done here is convert these from these values back into t values. So we know this goes from minus 1.6378 up to 1.6378. And we want to know what is this area here. Okay, so what is this area here? Well, if this is a t distribution, if it was a z distribution, you just use normal CDF. But as it's a t distribution, we can work out this area using t CDF. So we go into our calculator, into distributions, second distribution. As I say, if we're using a z distribution, we'd use normal CDF, but we're using a t distribution, so we use number 6. So we use number 6 t CDF. So what's the lower limit? So in this case, the lower limit was minus 1.6378. Our upper limit was 1.6378, and you can see it asks for the degrees of freedom. Okay, well, so we put those in. We put minus 1.6378 1.6378. We need to put the degrees of freedom in. So our degrees of freedom is going to be 3, because the degrees of freedom is n minus 1, so in this case 4 minus 1 is 3. So we put it into our calculator and we put in our degrees of freedom is 3, and then we work it all out, and it will tell us that this area is roughly 0.800 to be accurately 0.8. Okay, so this comes out to be 0.800. So that means this area is 0.8. Well, therefore, if the area is 0.8, our confidence level is approximately 80%. So we're 80% sure, in this case, that we're going to get t-values between these two values. Those t-values we've worked out and converted with that came from here. So the confidence level for this is 80%. Okay, so do some questions.